Hi, college algebra student. This video is for chapter 2.2, linear equations. So we'll explore how to solve linear equations that are involved with fractions and also rational expression. The first is to go through the steps. So if we see a linear equation that had denominator involved, what we can do is we would factor all the denominator in the equation, and then you exclude all zeros that would make the denominator 0. So this is the case when actually x is in the denominator. In a normal fraction like this one, you would not see x in the denominator, so there's nothing to exclude. But in other example, you might have x in the denominator. You want to exclude that even before you want to exclude values that would set it to 0, because a fraction should not have a denominator equal to 0. And then you'll find the lowest common denominator of all the rational expression in the equation. You clear the denominator by multiplying the least common denominator. You solve the remaining equation, and then you check answer to make sure that your solution does not include the excluded value. So the first one is actually just a normal linear equation that does not have rational expression, but it does include some fraction. So now this is the one that is different from the one that we did earlier, or in 2.1 or in algebra review, where there is only one x variable. So you see multiple x variable and there's multiple denominator involved. So what you do is, instead of combining like terms, you should actually clear denominator by looking at what is the common denominator that is common to all of them. So let's look at all the common denominator. So the first, we have a, we have 4, this is also 4, and we have 16. So what is the LCD of 8, or what is the lowest common multiple of 8, 4, and 16? And that is 16, right? It's 16. For 8, you multiply by 2, you get 16. For 4, you multiply by 4, we get 16. So we'll write this out, and then we'll say, well, both sides multiply by 16. And that means all of them had a 16 multiple. Minus 1/4 times 16 plus 3 over 4x times also 16. 1 over 16 times 16. The idea is to get rid of the denominator. 6 times 16. So this would have a 2 cancel by 2, cancel with remaining factor of 2. So 2 times 7 is 14, so 14x. And this would cancel. You see how the denominator get canceled? Minus 4 plus this also get canceled. And you have 4 left over. So 3 times 4 is 12x. So you see how this side has no fraction. And 16 and 16 cancel, and you still have 1 though. And then this one has no denominator, but you still have to multiply by 16. X. Okay. So now we combine like term just like before. This is just a linear equation. 26x minus 4 equal to 1 plus 16x. So just like before, we move all the x terms on one side and move the numbers on the other side. Plus 4 plus 4. We want the 16 on this side to go. So minus 16x. So I would have 10x is equal to 1 plus 4, 5, right? So, and then I divide 10x equal to 5. I divide both sides by 10. So x is equal to 5 over 10, which is 1/2. And that's the answer. And let's look, do we have any things I need to exclude? No, because the denominator are just numbers, so there's nothing to exclude. So let's do one where we really have rational expression in the denominator. So like this one. So our denominators are x, 3x, and 2. Okay. So maybe I'll just do this two side first. So what is the common denominator for all these denominators? I have 3x and I have 2. So the LCD would be what? 6x. So There's two ways to do it. You can multiply both sides by 6x, or you can change all of them to 6x. So I'm going to do the change them to 6x. So it's times 6 times 6. How do I make this 6x times 2 times 2? How do I make this one 6x times 3x times 3x, right? So just pretend that you're trying to add them. So you have 6x, 24, minus also 6x. Just pretend that you're trying to add them. 14 equal to 6x. 3 times 3x is 9x, right? So then you say, well, now I'm going to multiply 6x now. So all of the denominator goes away. So you would have 24 minus 14 equal to 9x, because then all this code goes away, right? All this goes away. So 24 minus 14 is 10. And then that is equal to 9x. Oh, I forgot to check what numbers should I exclude. So if the denominator, the lowest denominator is 6x, I should exclude 0, right? Exclude x is equal to 0. So if I solve anything, if it's equal to 0, then I should exclude it. So write this down even before you solve. I forgot that. And then you divide by 9 on both sides. So 9x is equal to 10 over 9. And 10 over 9 is not 0, so this is a valid solution. That's how you do it. You can multiply 6x earlier, but I find that if I do that, it's easier to understand. Example 3, I have 6 over x plus 2, 5 over x minus 2 equal to 20 over x squared minus 4. Before I do LCD, I should factor first. So factor, it would be 6 over x plus 2 plus 5 over x minus 2 equal to 20 over, remember how to factor x squared minus 4? Is both are square, so it's x plus 2, x minus 2. It's essential that you factor it, otherwise you would have unnecessary big common denominator. You see how this is just the LCD of both of them. So you would say the LCD, the lowest common denominator should be x plus 2, x minus 2. So all of them should aim to be this. So this is already done. I don't need to change anything. I'm going to change this with this denominator by multiplying what? Multiplying x minus 2 top and bottom, right? Because I want to have that denominator. So I would have 6x minus 2. The denominator would be x plus 2, x minus 2, right? I just want to make sure that I pretend that I'm trying to add them, although I don't need to. And then this is x minus 2, so I would pretend to multiply x plus 2 top and bottom. So the top would be 5x plus 2, right? So I'm just doing x plus 2, just x plus 2 like that. And then this is 20, is the denominator is already the one that we want. Oh, and also, by the way, what is the excluded value? I should exclude what? I should exclude, in order not to have divide by 0, I should exclude x equal to 2 and x equal to negative 2. So these two are excluded from the solution. Now I have all of them in the common denominator. I would just pretend that I am multiplying the whole thing by x plus 2, x minus 2, so that all these cancel. And so I would have 6x minus 2 plus 5x plus 2 equal to 20. Do you agree? And then I'm just going to solve it as if it is a normal linear equation. 6x minus 12 plus 5x plus 10, because I distribute, right? Equal to 20. And then a combined like term, 11x minus 2 equal to 20. Okay, so do some space here. And so plus 2, so 11x equal to 22. So x is equal to 2. Is this a solution? No, this is not a solution because this is excluded, right? Because we want to exclude equal to 2, so no solution. In case this is not x equal to 2, like it's 3 or 4, so that is a solution. But otherwise, you would say no solutions. The second part of 2.2 is about lines. If someone tells you there is a line that passes through 2 points, how do I write them? Write the equation of that line. This is very often is used to solve applications, so we need to master how to do that. So step would be find the slope of the pass through the 2 point, which is change of y2 minus y1 over x2 minus x1. And then you can write the equation right away as y minus y1 equal to m. So this is the m, the slope that you find, x minus x1. And then you rewrite it as y equal to mx plus b, like just do distribute and combine like term, or you can write it in standard form. So the standard form is when all the coefficient is an integer and a, which is the coefficient of x, is positive. So let's do an example. So suppose I have 2 points, 1 and negative 8, 7 and 3. So we can actually kind of sketch it out. What does it look like? 1 and negative 8, right? So it'll be like here, 7 and 3. So I want to find the equation of this line. It's kind of, yeah. What is the equation? So first I have to find the slope, right? M, y2, so label them x1, y1, x2, y2. y2 minus y1, 3 minus negative 8, over x2 minus x1, 7 minus 1. So that would be 3 plus 8 over 6. 7 minus 1 is 6, so 11 over 6. That's the slope. Second step is to write the point slope form. So the equation would become y minus y1 minus negative 8 is equal to m, which is 11 over 6, x minus x1, so in our case it's 1. Now this is point slope form. I want to write it as y plus 8 is equal to 11 over 6x minus 11 over 6 times 1, because times 1 is 11 over 6. And then I need to minus 8 on both sides because I want to do it as y equal to mx plus b. Okay, so this is minus 8. So how do I minus 8? 11 over 6. Common denominator minus 48 over 6. Because times 6 times 6. You can think of 8 is 8 over 1 is 48 over 6, right? Because you do times 6 times 6. So then you combine like term, you would say that is equal to 11 over 6x minus 59 over 6. And that is the slope-intercept form. So this is one way of writing it. You can graph it, right? And then you have to write in standard form. What is standard form? Standard form means all of them has to be an integer. So to do that, I multiply every side by 6. So 6y will equal to 11x minus 59. And then I want my x coefficient to be positive. So, and then the number on the other side. So I would write 11x minus 6y. Erase this first. Minus 6y is equal to 59. So I want the 59 on that side. So I plus 59. And then I want, so this is the standard form. Slope-intercept form, standard form. The next one is I have 2 points. I want to write the equation of the line. So you would try to do m, y2 minus y1, right? x1, y1, x2, y2. Oh, well, I think I run out of time, so maybe I'll do this in the next video.